Hello everyone, I welcome you all to the sixth video of Module 5, and this is the second video with respect to linear regression. Now we are going to talk about what is cost function, and specifically we'll be talking about mean squared error and how it can really help in this machine learning algorithm. So let's start this video and understand about this. So far what we have understood over here about the linear regression is that based on this type of data, you come up with this prediction equation. Now over here, because we are having two input columns or two input variables x1 and x2, each one of them will have its respective weight associated with them. So x1 is having w1 and x2 is having w2. And then we also have a bias value added to this equation. Now after this, what's going to happen? So we are going to find out the predicted outputs for each and every rows. But what are this w1, w2 and b values? Initially they are completely random. And the goal, as I had mentioned in the previous video, the goal of this machine learning algorithm for the linear regression would be to find that optimal values of this model parameters that gives you the best sort of predictions. But yes, initially because all of these values are random, what's going to happen? The chances are high that the outputs of the predictions will be completely off than the actual values. And how you know this? Because you will see that yes, for example, let's say in the first case, if I pass in the x1 and x2 values as 0.2 and negative 1.3, and then based on these random values of w1, w2 and b, you got some prediction, let's say as 100. So you can clearly see there is a huge difference between them. But now how does your model know about that? The predictions are not accurate. And that's where we come up with the cost function, where what is really happening? Now based on what type of problem you are dealing with, okay, what sort of algorithm, and then what type of problem with that algorithm you are trying to solve, everything is dependent on that. There is not only one cost function. There are multiple cost functions out there, and you use one that is suiting your whatever use case you are trying to solve. For example, the one that goes really well with the linear regression is the mean squared error and the mean absolute error. Now I'm going to show you this whole example with respect to mean squared error, but the ways that I'm going to explain over here with respect to the MSE, that is the mean squared error, will be same for all the cost functions. And you will also realize this once we'll be studying the theory of the logistic regression. At that time, we have again a different sort of cost function. But coming back to this, that how does your model realize that there is a problem with this prediction? So for that, let me just have a very quick demonstration over here. The true values or the actual values that is present in your data. Let's say it's 0.3, negative 1.8, and let's say maybe 2.6. And because the model parameters are random in your first iteration, let's say the predictions are completely off. And let's say we have 100.8, then over here for this 26.3. And over here, let's say we are having a negative value like negative 85.6, random values that came to my mind, okay? But now, how do you get that cost function? Because we are dealing with the mean squared error, let me explain you everything with respect to that mean squared error. So first of all, I am going to find out what is the error between actual value and the predicted value. That means what is the difference between them. So if I'm writing my mean squared error, this is my MSE. It stands for mean squared error. This will be what? It will be the difference of the actual and the predicted value. So that is y minus y cap. And then after having the error, you square that error. So how is it going to work like? It's going to be like, 0.3 minus 100.8 square. So that is the square of the error. And then you take mean. But how do you take a mean of that one value? It's actually not just one value. We repeat this kind of process for each and every row that we are having in the data. So let's say if this is row 1. So we do this for row 1. Then we do it for the row 2. We also do it for row 3. And just like this, you just keep on repeating this kind of steps for all the rows you are having in your data. And then take a mean of it. So the way that it works over here is that let me just give a I over here that denotes the number of rows over here. And now I'm going to sum all of this squared errors we are going to get from every rows. That's going to start from I is equal to 1, that is the first row, till the last row. And let's call n as that last row. And then I'm going to take an average of it. So let's say if I'm having two values, how do I take average of two values? I add these two values and divide it by 2. If I'm having three values, I add all these three values and divide it with 3 instead of 2. So that's exactly what we're going to do over here. After getting the squared of all the errors, you sum them up together, and then take a division with the total number of rows in the data, that is n in our case. Or you can also simply multiply this thing as with 1 by n, and that's also the same thing. So this is your cost function that we are going to use for your linear regression in this particular program. So what's happening essentially? Now your model knows, based on this mean squared error, if this value is high, it means your model needs more training. Model needs more training. And if this value is low, it is good sign. It's a good sign. What does it indicate? It indicates that model needs less training. Model needs less training. And if this cost function is converging after every iterations, you are saying that the cost value is low, and apart from being a low value, it is also converging. And so if it is getting converged, excuse my spellings guys, so if it's getting converged, in that case, that's where we can stop the training. We can stop the training. Why? Because now we are having this kind of a surety that initially it was having a very high value. After that high value, as we go ahead in the training process, because you are trying to train your model to learn this kind of optimal values of the weights that are W1, W2 and B. So until you find that good balance between these model parameters, you will get a high value of the mean squared error. And the moment your algorithm starts finding or going closer to that optimal values of the model parameters, you will start seeing low value of the mean squared error. It means that the predictions are getting better. And when do you know? Where predictions are not updating only, like it's not improving, it's just same. Maybe it could be very close to the actual value, maybe far, but it's not improving any further. It means that your cost function has converged, and that's the optimal values of the predictions that you are able to get based on that algorithm that you are using. In our case, that is linear regression. So yes, that's how this cost function actually works. And now what's going to happen if the mean squared error is high? How does your model learns to optimize these values of the model parameter so that in the next iterations, you hope to get a better prediction, at least not way off as compared to what it is currently. So that process is called as optimization. And that's what we're going to look into the next video. So yes, that's it about this video over here guys. And I hope that you were able to understand that how do we relate this kind of cost function in order to check if the model is performing better or not. Now in the next video, we're going to look into how we can optimize this cost function with the help of optimizer like gradient descent.